So you hold that. So what I'm going to do.
It's already open.
Oh, what we were going to try and do is
That's
started sampling now of this. Start sampling. But you're not going to move at all now. I'm just so that's leaking out. Right? If I now open
So this valve is also leaking, by the way.
so the valve is leaking. You see that? So we've now just shown that the valve has also got a small leak, which is probably why you've lost all that well pressure between the last time you were here. But in terms of numbers, we are 0.01 CFM. That's that leak. Now, if you just keep it going and move it off, and what's the parts per million?
400.
So, and about 400 parts per million, and now background. I tell people never to bother zeroing the device unless you know you've got zero background. Right? You could have 20 ppm from the fittings over there, and I guess it's because we're always doing 1 or 2 ppm of zero. What's it say now?
It went down to
3 ppm. Well, 3 ppm between friends is not a lot of leak, right? And even this very small leak was, did you say it went up to 400 ppm? So we could go down an order of magnitude without any problem. And I visualise those leaks when I show people in a lab environment, and I have methane bubbling through, I don't know, a glass of water. One bubble, another bubble, another bubble, and that's going down to your 1 gram per hour type rates. So this morning we quantified something at about 1 kilogram an hour, I think we said. The one over there was around ½ kilogram an hour, and this one obviously less than that. Just to put it into context. But again, you know, this thing will go up to 25 CFM without any problems. I hope you never measured them as 25 CFM. Right? No.
If you do, stand well back.
Any questions?
Yeah, I mean, pretty much, you know, there's so many wells out there, and the only thing I really feel like that, as far as what I've been trying to do the past several months, is just try to come up with an as efficient as possible methodology to go out and survey as many wells as possible in the short amount of time frame, find out, one, are they leaking or not, and then once you find out they're leaking, capture that data and have verifiable data that you can capture with that, and then of course directly measure so you can prioritize. So, you know, if you know, of course, if you guys need but we're here, you know, I mean, basically we really want to listen to what you guys want. So if you guys have anything, any ideas, or if there's any particular thing, we want to hear about it, because it's kind of what we're trying to figure out is what everybody wants right now. So, but basically this methodology, I mean, the lasers have been used. We first introduced the TDLES handheld laser technology in 2005, particularly for pipeline leak detection for DOT leak survey compliance. So we utilize the lasers heavily today in the downstream distribution for pipeline leak survey. We also have first responders, fire departments that use them for checking. You can shine through a window of a building to find out if there's gas inside a building with a handheld tool and let them know, is there gas, no gas. So it's really become a great first responder tool. It can really tell you if you immediately have an emergency situation or not. It's a standoff tool, so if you are dealing with blowing gas, you don't have to worry about having to get right in the plume to try to figure out what's going on. You can get a good idea from standing remotely, but you know, for safety reasons, particularly if there's a lot of other, if you're in a basin that's got a lot of other, like benzene and other things in the air that you want to protect yourself with. But I mean, you know, but the high flow methodology, you know, like I said, this has been around for 20 years or so, more than 20 years now. But David Booker. Like, I've just been really impressed using different ones over the years. This one is definitely, I'm kind of biased towards it, but it gets the job done, in my opinion, as far as anything from real small to real high. You know, and you can get good quality data with it. Just as far as, you know, how we capture that, we can capture second by second data. So we can really do a lot of characterization, you know. So if you have a lot, sometimes what happens with these wells, they do a lot of this. So you see them, like you said, they're you know, mentioned they're breathing. So you can actually kind of see the breathing going on with a continuous flow measurement device. So yeah.
Somebody have questions over there? We have a couple questions over here.
Yeah, absolutely.
Battery life.
So yeah, I mean, if you got the battery, you can run it for a full whole day. Is what I'm seeing. So you got a good whole day's battery life out of it, but you can swap batteries very easily.
Can you show us how to take the battery out?
Well, okay, so when we've designed the product to last a full typical shift of leak detection and quantification at the maximum flow rate. Because of the safety certifications we're looking at exploring, not just within the US, but also in Europe, we don't allow you to charge the system while it's in a hazardous environment. Okay? I don't know why we do that, I think it just makes sense. You equally can't change the battery. So our consultants have advised us that making batteries easy to change is a hard process for safety certification.
So I think that leads into my follow-up questions. One, what is the expected useful life of your equipment? And two, what are the expected, like, what is an average tech going to have to do to maintain your equipment?
So if it lasts more than 5 to 7 years, my CEO tells me off and says it was over-designed. Right?
Okay.
No, I'm joking.
Sorry.
Well,
I'm
okay,
a finance person.
let me answer that a little bit. The lasers that are in these devices, I mean, we've been making handheld lasers like these, the TDLES lasers, since 2005. We still have old units back from 2007 that we're still maintaining, supporting.
Cool.
The nice thing about an infrared technology, it doesn't get contaminated. The sensors don't get poisoned. It's just a simple light path, you know, that you're passing the sample through. And then really another thing is that this thing, I mean, is as far as filters and general maintenance, keeping your filters clean, there's really, you know, as far as the old backrack, we used to have problems with sensor drift. No sensor drift issues really with this. We're really more or less auditing the machine every year to make sure that it's still within span.
I can't give you an MBTF,
It's very stable,
right?
Yeah.
But I would imagine it will be in several years, 3-4 years.
Okay.
Yeah.
And routine service and maintenance, I suspect you'll be changing the lithium-ion battery pack before that because it's a lithium-ion
Right.
battery pack.
Yeah.
But
Would
it's
that
just,
happen through you, or would that happen through the owner of the machine? Since
I personally like to keep it as simple as possible. I was having a conversation earlier. You saw that hose that Sean brought out. We're currently going to be supplying the end hoses and telling you the vendor where you can buy the hose.
okay.
Buy it by the 250 foot and cut it however long you want. Right? Otherwise, all we do is feed FedEx. No, we try and keep it so that you're in control. We know that as soon as you go in the field, you want solutions, right? And being able to change the battery pack, it was actually a good question. If you had to change the battery pack on this,
Yeah.
you'd remove these screws. Now, Sean puts this on a plane, and you know you're not allowed to take lithium ion on a plane, but you can have it in hand luggage. So look how smart this guy is.
Yeah.
What an engineer! Right, he's put the Allen key on the back, so he gets an hotel room or whatever. No, it's a 5-minute job,
Okay.
but we've not made it like
Gotcha.
power tools. Right?
Gotcha.
The battery compartment's right down here, so you just pop this cover plate off, and the battery gets
That all that's in
Yeah.
there
But-
is the battery.
Yeah. Oh no, and the optical bench and all the other I/O lines and all the rest of it. So that's quite a smart box. Tonight, if somebody wants to know what was inside of it, ask me and I'll show you a picture. I'm not going to give you the picture, but I can show you on the phone what's inside.
That's fair.
So I mean, my thing is I used to use a cat bead and the thermal conductivity cell sensors, you know, that typically what we use in a traditional handheld combustible gas indicator. And we just weren't able to get the sensitivity we needed with those type of high flow samplers. And this thing purges out, zeros very easily. It's speaking just from my many years of using this type of technology, this thing's a lot more quicker, efficient. And it's just got better data logging capabilities, especially quote unquote, if you're going to use it I mean, it's technically a cash register box, especially when you start considering your carbon, you know, when you're trying to capture credits and everything. So the data, you know, is all time date stamped. So it's you can go back and it's self-auditing, and it has a lot of self-auditing features as well. So yeah, absolutely.
To be clear, there's no calibration required.
Oh, like once a year.
That's separate, but
That's a good question. The first one is there any calibration? What is a calibration? It's an adjustment of the instrument to read what you believe it's right. So if you know how to do it properly, your procedure should be you don't calibrate until you've audited it. If you fail an audit, was it the last week, the week before, is all that data useless now? So you should never fail a calibration. So we are recommending audits. I can tell you and I can show you that it doesn't drift from one week to the next. But I'm not going to take legal stuff. It'll be down to your own QA procedures and say, I want integrity, I want an audit test, maybe a weekly or whatever. Then you build up your own QA metrics and say, look, we can demonstrate compliance weekly, now we'll relax it to monthly. A bump gas audit test on that takes 2 minutes and probably costs $5 in gas. It's not zero, it's probably $5. So we are recommending that you do that, and we're recommending you get it audited once a year. That's because, you know, we like service records, right?
The other thing too is that with this being methane specific, it doesn't get cross-contamination from other hydrocarbons and the heaviers, which we found, you know, that this basically is really right on the money when it comes to methane emissions. So even though we were quantifying that, there was other stuff in there. Whatever we're reading and measuring here is just methane. So if that just to help, I think I mentioned it earlier, but I didn't really emphasize it really very well. So we're measuring the whole gas flow, but what's coming out on our register is the volumetric emission rate for methane gas. Because just like these lasers, the laser's specific to methane. If we put a propane tank on it, for example, it won't see a thing.
So last year in Colorado, METEC, CSU, was funded by the California Air Resources Board to develop an open source high flow sample, Dan Zimmerle's group. And they started producing one, never finished it because we kind of said, look, we want to get involved. So they tested out our units and a couple other prototype units at that stage. And they concluded with the gas systems that don't have like TVLs, you need to calibrate them on the gas that you're going to be measuring. What does that mean? It's difficult because obviously butane, propane mixes change and sensitivity change. Oh, ours, yeah. Oh, yeah, it's so narrow. Yeah. But it's also, anybody who wants to know about spectroscopy.
Yes.
Well, yeah. So if we measure the methane accurately, we can get back to total rate quite accurately knowing we know what that gas is.
You can also fill up the background sample. Just get a sample bag, fill up, because it's IR based, there's no combustion. You can just get a bag, run to a master bag. You can get your gas composition that way as well. So if we're trying, because we don't know what the composition is in here, we have no idea. But you can always fill up a sample bag and run that master bag.
So can I ask a market question? I've been told it'd be nice to have a hydrogen sensor and a CO2 sensor. I know, yeah. big is the transport cost.
Yeah, I think it was. So I think eventually it's going to be a good market.
And CO2 is a diluent that's quite often present in people like to quantify that. That wasn't a yes, go for it.
I mean, are there any hydrogen sensors that are cheap and don't drift?
Well, that's a much better question.
I mean, I would get that in the gas competition, so if I do the whole gas,
Okay. Yeah.
you'll see as a methane factor.
Yeah, it's interesting.
What you normally don't get in a competition is hydrogen.
Now, it's been pushed strongly in Europe, and it's going to come here at some stage where we start pushing hydrogen down the line. That's a challenge on a whole range of other parts of the construction line and all the rest of it.
Do you see anything else that Will had over there?
I don't know. I'll have to check. Check.